the index vector I is a vector with all the index variables of a loop. And the index values of L, the loop L, are the values of these variables. Then the index space of L is the subspace of Zm, which consists of all the index values. Okay, so a fine array reference, which is what we want to, we hope that the loops contain that, only that. It's an array reference in which all subscripts are linear functions of the loop index variables. Sometimes a loop can be analyzed and parallelized without the references satisfying the criteria to be affine. Such as in this example, which can be analyzed using symbolic analysis. This example comes from a collection of loops called the Argonne test suite for vectorizing compilers. And it is a collection from real codes used for supercomputers, which is collected by the Argonne National Laboratory in the United States. In this case, it is more complicated to analyze the loops, since we don't know, in the first case here, we don't know the value of x. And in the second case, typically we don't know the values of c. And here we have an example of a nonlinear function, and it cannot be analyzed by the techniques which we will see soon either. So, so how do we represent array references? We represent them using a coefficient matrix and a constant term. So for the first subscript, we have this column, and the second subscript, this column, etc. And we can look at an example to start with. So the first column is this subscript, and the second column is this, and then the constant term, well, as we can see. So what we want to determine is if there is a data dependence between two iterations, between two different iterations. And how can we do that? Well, the criteria is that two iterations access the same array element or matrix element, and at least one of them is a write. If both read, then we don't care about it. I mean, it doesn't limit parallelization. But if at least one of them is a write, then we want to know if they can reference the same. And how can we know that? Well, as a start, we can set up this equation. So I here is one index vector, and j is another. They both use the same loop variables, but the different instances of them. Okay, so they represent different iterations. And if there is an integer solution to this, then there may be a data dependence. It's not certain, because the solution that we find must be within the loop bounds. Okay, so what we do is to write this, I mean, this is just comparing if they are for the same array reference, same array element, and then we write it like this. But it's more convenient to have only one vector of unknowns, so we write it like this instead and use x here. And in order to confuse, no, not really, but we replace this a and minus b with just a. So it's a different a.